Okay guys, we're just going to go over a few things concerning logarithms today. So to start off with, we have, why isn't it, okay, let's go logarithm of x minus 2 base 10 equals 0. This is one of the simpler problems that you're going to have. And so, as you know, if you're in our class, you have Glennon, and he has taught you that the 7 formation goes from here all over here, which just means that you can rewrite this problem as 10 to the power of 0 equals x minus 2. And of course, anything to the 0 power is 1, so you get 1 equals x minus 2. And then if you move everything over to where you want it, it can be 3 equals x or x equals 3. And like you check that because you don't want there to be a negative or anything over here. So say that if x were 1, you would get log of negative 1 base 10 equals 0, which can't be true. So 3 does work because you get log of 1 base 10 equals 0, which is true. So go ahead and put that in your solution set. Okay, so now we'll do a problem where our log rules actually come into play. So you see here that we have terms that have the same base. You can actually convert into log of x times b base a. So you actually multiply the x and the b if they have the same base. So we're going to start off with log x plus 7 base 2 plus the logarithm of x plus 8 base 2 equals 1. And if you convert that using the rule up here, that becomes log of quantity x plus 7 quantity x plus 8 base 2 equals 1. And then you can do your 7 formation, so that means that 2 to the first equals these quantities multiplied, so we'll just multiply them right now, so that becomes x squared plus 15x plus 56. We know that 2 to the first is 2, so we'll just subtract right away. So that becomes 0 equals x squared plus 15x plus 54 if you subtract the 2. And this can be factored, so there's no need to use a formula. So that becomes 0 equals x plus 9 quantity times x plus 6. So if you solve that, you would get that x equals negative 9, x equals negative 6, except, so you can never have, say, log a negative b. You're never going to have that for reasons I'll explain later. So within this problem, say that you enter in x is equal to negative 9 for the first one. You would get log of 2 negative 2, which can't happen. But if you do the 6, then all of your numbers within the logarithm are positive. So x equals 6 is your only solution. So put that into your solution set. Okay, now we have a problem that deals solely with natural logs, and they follow these same rules that logarithms do, so you can once again rewrite it as natural log of x times x plus 1 equals 1. But in this case, this is special because we know that only the natural log of e is equal to 1, so what you can do is you can set x times x plus 1 equal to e. And then multiply that out, you get x squared plus x is equal to e. Bring e over to the other side, and then you have yourself a full quadratic equation. So we're going to put that into the formula. So we get x equals negative 1 plus or minus the square root of what the b is 1, so 1 minus 4 times a is 1 times c, which is negative e, all over 2 times a, which is 1, so don't worry about that. Then we get x equals negative 1 plus and minus. Then when you simplify the top part, you get 1 plus 4e all over 2. Now you can't simplify that anymore, except for you know that the natural log of anything is never going to be negative, so for example, you can't have natural log of negative 1. And if you do negative 1 minus the square root of 1 plus 4e, you're going to get a negative number. So we're going to not use the negative, so then your only answer is going to be x equals negative 1 plus 4e all over 2. And then you'd write that in your solution set. Negative 1, oh, that's a terrible negative. 1 plus 4e over 2. Except math team people don't write the solution set because, nobody really knows what that is. Okay, and now we're going to use other rules with this logarithm equation. So before we had that if the logarithm has the same base and you're adding them, then you can multiply things here and things here together. But now we have it's a minus sign. So what you're going to do when that happens, you're going to use the rule that says that you divide them. So this actually becomes log of x over x minus 1 base 4 equals 1 half. And then once you use your 7 formation, it becomes 4 to the 1 half equals x divided by x minus 1. And you know that 4 to the 1 half is actually the square root of 4, which we know is 2. So we get 2 equals x divided by x minus 1. Once you cross multiply, because you know that 2 is actually 2 over 1, then you go, x times 1 equals 2 times x minus 1. So 2x minus 1 equals x. Let's bring that up over here. 2x minus 2 equals x. If you want to clean up the x's, you subtract x from both sides. You get x equals, and then add 2 to both sides, x equals 2. You look at it in the original problem, you're not going to get any negatives within the logarithm, so your answer is 2. And now we're going to work with a more classical equation. So here you see you have 2 to the 2x plus 2 times x plus 2 minus 12 equals 0. And you can see that that follows the form of a quadratic equation. But you don't want to solve it with the the two x exponents, so you're going to use a u substitution. But before you do that, you're going to want to split these terms into their parts, so this stays here, except for this one. When you multiply exponents, you add them. So this is actually 2 to the x times 2 to the second minus 12 equals 0. And then you can substitute. We like to use u substitutions, but I prefer a, so we're going to use a. So a equals 2 to the x. So when you rewrite that, you do a squared plus 2 squared a minus 12. You know that 2 squared is 4, so a squared plus 4a minus 12 equals 0. Factor that. A plus 6 times a minus 2 equals 0. A equals negative 6. A equals 2. Be careful. You can't have, You can't have 2 to the x equals anything negative. So this is out. But when you check this over here, then you get 2 equals 2 to the x. Obviously 2 to the first is 2, so x is going to be equal to 1. Okay, so now we're going to do some more math teamy problems. So this is a classic example of what you might have on a CMLS test. So the directions here are just to simplify. And we know that, say, log of a base b can be rewritten as natural log of a over natural log of b. So we're going to apply that to the above series of logarithms. So that's going to become natural log of 6 over natural log of 4 times natural log of 8 times natural log of 6, continuing natural log of 126, natural log of 124 times natural log of 128 over natural log of 126. And since these are all their own terms and it's multiplication, you can cross cancel. So these are out. This is out with its counterpart within the dots over here. This is out. This is also out within the dots. Just look within the dots. and then this becomes natural log of 128 over natural log of 4. Okay, and except for you can simplify this. So you can split up 128 into its parts, so that, except now you can simplify. So you know that 128 is actually 2 to the 7th, and that 4 is 2 to the 2nd. So you can move the exponents out. So that becomes 7 natural log of 2 over 2 natural log of 2. Technically, the natural log of 2 is one whole term, so you can cross those out, and your final answer is 7 over 2. Okay, so this is a much more math teamy type problem, once again. So this is one of the more difficult ones that you'll get because it entails both logarithm rules and the rules of summation. So we're going to start by rewriting the logarithms as the natural logs. So this becomes natural log of 2 over natural log of 2 plus natural log of 3 squared over natural log of 3 plus natural log of 4 to the 3rd over natural log of 4. Okay, we're going to keep it at that for now because what you can see here is that natural log of 2 over natural log of 2 is just 1 because they're the same term, so 1 plus. And if you move the if you were to move the exponent here over on in front of the natural log of 3, then you would get 2 times the natural log of 3 over the natural log of 3, which means that once again these would cancel out, so you would get 2. The pattern would continue over here, and this would be out, and then the 3 would just go in front. So you get 1 plus 2 plus 3, dot dot dot. Pattern continues over here, so don't even worry about the n plus 1. It's just n, and then equals 1,992 n. And now you have something that you can put into a summation, and we know that the formula for a summation is sum of n equal, this is arithmetic by the way, because you're just adding, n over 2. We're going to use the simpler type equation because we have both the first term and the nth term. So we're just gonna go a1 plus a n, and we know that this whole big series here adds up to 1,992 n. So this number here will be s of n. So you write it like this, n over 2. We know that the first term is 1 plus the nth term, which is n. We're going to multiply by 2 to get rid of the fraction, so that turns into 3,984n equals n times n plus 1. We're going to divide through by n's because they're the same on both sides. So 3,984 equals n plus 1. Subtract 1 on both sides, n equals 3,983, and you have solved for it. And just a quick word on negative numbers within logarithms here. So, say that you have this, so logarithm of -1 base 2 equals x. Well, you can rewrite that as 2 to the x equals -1. But you're never going to get a negative. Things are just going to be getting smaller, because if you say that you have 2 to the 0, that's 1. 2 to the 1, to the first, excuse me, is 2. 2 to the second is 4, and so on. You go the opposite way. 2 to the negative first equals 1/2. 2 to the negative second equals 1/4. You're never going to get a negative, so therefore this cannot happen. And that is the end of the log video.